All right, here's example 2.2 from OpenStax PreCalculus. Here we're kind of just defining or coming up with an example that uses the terms increasing, decreasing, and constant. And you can define those a few ways. I mean, here's your book's definition right here. It's when you have a linear function, the slope is a number. And is that number greater than 0, less than 0, or equal to 0? And that tells you whether the function is increasing, decreasing, or constant, respectively. So you could do this problem this way, or you can kind of just use common sense to talk yourself through it. So what I'm trying to decide, there's 3 scenarios here, and in one of the scenarios, the linear function is increasing, when it's decreasing, and when it's constant, and I'm supposed to match those up. So if you read through, it says that a teenager sends on average 60 texts per day. Okay, fine. The total number of texts, so A here, the total number of texts a teen sends is considered a function of time in days. So your output is the total amount of text you've sent, and your input is how many days it's been. So when it's been 0 days, you've spent 0 texts, but after 1 day, you've sent on average 60 texts. And after another day, 2 days total, you've sent a total of 120 texts. You sent 60 more, and so on. So as your input goes up, what happens to your output? Does it go up, down, or stay the same? If it goes up, that means your function is increasing. If it goes down, that means your function is decreasing. If it stays the same, that means your function is constant. That's exactly the same as this definition here when we're talking about slope, because the slope is how much the output changes by every time the input changes by 1. And so if that's a positive number, your function's increasing. Anyways, the total number of texts a teen sends, that would be an increasing function. And your book explains it because they write it as a linear function, f of x equals 60x. Okay, fine. The input is x, and so the slope here is 60, and 60 is a positive number, so therefore this function is increasing, and that's fine. Another way you can look at it is it's increasing because the output goes up as the input goes up. Because, how about this? Because as the input increases, so does the output. Same, just another way to look at it relative to what your book said. Okay, so the second one here, a teen has a total of 500 texts per month in his data plan or her data plan. The input is the number of days, and the output is how many texts are remaining for that month. So you could again write it as a linear function. You could say, well, when time is 0, you have 500 texts remaining, but then every day you use up some text, so you have less and less remaining. So my linear function would be the 500 that I start out with minus 60 times x, where x is the number of days, because each day I lose 60. And usually you don't, if you're writing it in linear form, I think this makes the most sense, but it's not in that y equals mx plus b form. So you could rewrite it so it looks like this, just so it fits the form better. I think this one is more intuitively appealing, whereas this one fits the form better. But at either rate, in either example, your slope is negative 60. So this function must be decreasing using your book's definition. Another way to see that it's decreasing is because as the input goes up, the output goes down. Because again, the input is how many days into the month you are, I guess, and the output is how many texts you have remaining. So later in the month, you have less and less and less texts remaining. Yeah, I guess that's good enough. Okay, and then this last one here, a teen has unlimited number, process of elimination, I guess, to figure out your answer, or we can actually read through it. A teen has an unlimited number of texts in his or her data plan for a cost of $50 a month. The input is the number of days, the output is the total cost of texting each month. So the total cost of texting, maybe I should label these a little better. This was B up here. I didn't even write the function for A. I guess it does say find the linear function that describes it, so I should write that for A too. For A, I got f of x equals, and then we do 60 every day. And I'm going to write plus 0, even though you don't have to write the plus 0. You might argue that it's simpler if you don't write the plus 0. But when you're just learning linear functions, it's kind of nice to have 2 terms here. This one's the y-intercept, this one's the slope. So I'll put the plus 0 in there just to make it a little more illustrative. Okay, so for this last one, a teen has an unlimited number of texts in his data plan, costs $50 a month. So, okay. the function where the input is the number of days and the output is the total cost. Well, you're paying $50 no matter what, no matter how many texts you send. So f of x equals 50 would be the function. I might write it, even though this might seem stupid, maybe I'll even write or f of x equals 50. I guess if I'm going to be consistent, I said it's kind of nice to have two terms here so you can really recognize, oh, there's the one that has the slope in it and there's the y-intercept. So in order to do that, you'd have to put a 0x here, which is kind of strange because 0x you won't really see because 0 times anything is 0, so why even bother writing 0x? True. But if you write it like this, it's easier to see that the slope is 0, and when the slope is 0, we have a constant function. So I would say this is constant. And my argument for y, slightly different than what your book will say here, I'm kind of just doing it different to give you another way of looking at these. I would say that it is constant because as the input goes up, the output stays the same. I'll call that good enough.